Hey everyone, this is Matt Perez, and in this video we're going to talk about the Loft feature. Now with the Loft, we have a solid lofted boss base, we have a loft cut, we also have a loft surface. Now because there is so much to cover in this example, talking about different ways that we can create our profiles and so on, we're not going to cover the lofted cut. It's going to be exactly like the lofted boss base, just like the sweep cut was like the sweep boss base, the revolve cut was like the revolve boss base. So keep that in mind that there is a lofted cut, but we're really not going to talk about it here because we have so much to cover. Now I want to start by mentioning the main difference between a sweep and a loft. A sweep requires a profile and a path, where the loft requires a starting profile and an ending profile. You can have a centerline path and guide curves for a loft, just like with a sweep you can have guide curves and a centerline path, but it's just a matter of what's physically required. Just like when we get to a boundary, you can have a profile and a path, a starting and ending profile and a path, or just two paths, or however any number of combinations. It's sort of a mixture of a sweep and a loft. So let's go ahead and jump right in and take a look at our example. So to get started, we're going to go up to our feature tab and select lofted boss base. The first thing you're prompted to fill in is a profile. Now in this case, we're going to use 3 profiles, but I'm going to start by selecting the circle. And you'll notice that it prompts me with the selection manager. And this is because this circle and this slot are both inside of the same sketch. So you can use a single sketch, especially if you're going from one profile to another that are in plane, and just put it all in one sketch. It makes it a lot easier to control. Now the first thing we'll notice here is, one, it's not really going to make anything that's worth sending home. I mean, it's really just smearing the shape along, and if we hit OK, it's probably going to fail. Actually, I know it's going to fail. It's not going to make anything. But I want to note that we have these green dots, and the green dots are locations for, let's just call them the fixed points, or the foundations for the shape. It's going to go from this point to this point. And the reason I want to mention this is because this happens a lot. You go from something like a circle or an ellipse that doesn't have a starting and an end point on the sketch segment. It is just a continuous entity. Whereas the slot is 2 arcs and 2 lines. The green point has to snap to those endpoints of the sketch segments. And that's a main difference. When you get into something like a boundary, this can free float along anywhere, but in a loft, it has to end on an endpoint of a sketch segment. So it complicates things a little bit for us, and I'll expand on that a little bit when we get into the surface section. So now that we're looking at this, I want to add this third profile in here. And when I do, the preview fails. And before, it really wasn't very good. It was smearing it, but now the preview just doesn't work at all. We have to go up to the profiles with sketch 3 selected and move it up. And basically we're reordering everything. So as we look at this, we get a preview on the screen, and it looks kind of funky. It's probably not what we want. And this is a problem with controlling a loft with these closed profiles using things like circles, because it's heavily dependent on where these green dots are. If I drag this one green dot up here, it's going to give me a different shape than if it's down here. So this is something that you need to keep in mind when you start talking about using something like a closed profile here to make your loft. You have to be very, very careful with it, and ultimately the end result is probably not going to be what you wanted, because you have to be so delicate with where these points are. But now that we're talking about this, let's just briefly talk about guide curves and centerline paths. A centerline path is going to be something like this arc that goes through the middle point of all of our sketch segments. And that's important because it has to go through the middle of all sketch segments if you want it to be considered a center line. Now, this center line cannot be used as a guide curve. A guide curve must intersect the sketch profile. So the center line doesn't hit any of the sketch segments anywhere. It just goes directly through the middle of the circles and the midpoint of the center line for my slot. So we can't really use it as a guide curve. We can use it as a center line if we want. But of course, we have to drag these points over and get this thing as close as possible. Now there is a section called options in here. And if we go a little bit farther down, there are 3 things in here. Show preview, pretty self-explanatory. Close loft it will physically try to close the loft and make a closed loop here. It's pretty finicky because most of the time when you're doing a loft, you're dealing with probably some complex shape. It's not going to be very simple, and probably about 50% of the time it's not going to be able to physically compute it. The requirements to close a loft is going to be 3 profiles. You must have at least 3 profiles, and it'll take the first one and the last one and try to connect them. The next thing is merge tangent faces. This applies to things like this slot because it's 4 segments, and each segment has a tangency relation between the arc and the straight line. It will create a separated or segregated face on the resulting body. Now, if you select merge tangent faces, it'll blend all those in and it will try to make it a single face. It doesn't always work. Again, it's heavily based on your sketch entities. If you're going from a square to a rectangle, that's simple. There are hard edges. There's no tangency. If you're going from an ellipse to a different shape ellipse, it's again, there's no start and end point, very straightforward. If you're dealing with something that has these multiple sketch segments on it, well, then you probably want to play with this merge tangent faces and see what your end result is. Now that we've created this sort of random looking shape that we can't really do anything with, let's talk about another thing that we can do with lofts. So I'm going to go to another example here and talk a little bit more about some of the options in the loft tools. So we're going to loft this thing. We're going to go from this profile to this profile. Now this is pretty straightforward because now we have sketch segments. It's actually the exact same profile, sketch segments that we can take the green point from one to the other and not worry too much about it. Now inside here we have start and end constraints. Most of the time you're going to do normal to profile if the profile you've selected belongs to a solid or a surface, and you can get edge relations like tangency or curvature. Those will be shown here inside of your start and end constraints. We also have a direction vector. This can do things like help you apply a direction. And in this case, we don't really have a good example, but if you want to have like a straight line in here or select a plane for the direction you want this thing to go, then you can use that to determine the direction that your loft is going to start out in. Now for us, what I want to focus on is going to be the guide curve. Now this guide curve intersects our part, intersects all the edges, and what we want to do is we want to look at the different options inside of the guide curve section. So we have a drop down that by default says to next guide curve. Now if we change this to next sharp, you notice that it looks a little bit different. It's essentially taking this guide curve and it's taking it all the way down to this sharp edge. Everything else here is blended, filleted, or whatever, but there's a sharp corner here. So it's taking this transition and it's blending it in all the way across the body, but it's sort of minimizing it once it gets to this point. If we say to next edge, then it stops it once it gets to this sharp transition edge. This is an edge, not a fillet, not a blend. So you can see that it allows me to push the shape out over here, but keep it exactly like the profile on this edge. And then we can do global, which applies this edge everywhere. So you can see that the sharp corner has that same arc on it. This edge has that same arc because it's applied globally. So if we go back to next edge, it's probably what we want here. And then for the tangency options, we can do a normal to profile, which changes the way this looks. We can do a direction vector by selecting a plane, or we can say none. So that is another way that we can talk about creating this loft using sort of these funky shapes here. Now I want to go back to my first example. I want to delete the solid and I want to talk a little bit about doing this as a surface. Now, one of the benefits of using a surface loft is you don't have to have a closed profile. To do a solid, you have to have a closed profile. Otherwise, it's not really going to work out in your favor. You have to approach this by figuring out what you want to make, what you want to do. And the way that I approach something like a loft is I always start to think out, is it symmetric? If this thing can be mirrored, only model half of it because your control will be that much better. So I'm going to start out by taking a look at my original sketch, sketch 1. So inside here, what I want to do is I'm going to draw a horizontal line. I'm going to make this horizontal line for construction, and then I'm going to trim this and I'm going to trim my slot. And it's going to say that I'm going to lose the fact that it's actually a slot, and I really don't care in this case. I'll just add a few more dimensions. Make sure that I have relations on these, they're vertical, and make sure that there's a tangency across these. Just quickly add these relations to make sure that it's fully defined. Lastly, we need to determine how far it is out from here. And you see that it can still float around. We want to make sure that it has a coincident relation. All right, so now that I have these points, I have this circle up here, which I'm going to do the same thing. I'm going to draw a vertical line through this one using its snap points, make it construction, and trim it. Now you wouldn't have to go back and do this if you originally designated this thing as a surface loft. And the last thing I'm going to do is on my, in this case, my front plane, is I'm going to draw a few arcs. Now the important thing here is that this arc uses the pierce relation. So I'm going to pierce it here, and I'm going to make sure that it pierces here. Now you'll notice this one gives me an error because it's trying to use a midpoint, but if we get away from the midpoint and we just do this point, make them coincident, it works out okay. I'm going to do one more arc. I'm going to go from this point to this point, and then make sure again that these things pierce or are coincident to make sure that they hit all the guides. Then I'm going to go back to sketch 2, and I'm simply going to hide it. I don't really need the center line. Go to my surface tab, and this time we're going to do a lofted surface. So we're going to go from here to here. And you'll notice something different happened here. By default, it didn't automatically open that selection manager. So what we have to do is right click, go to our selection manager, and then manually grab these entities. Again, right click, selection manager, grab these, and say okay. So now as we're looking at this, the problem is this green dot. It needs to be, again, in the right location as it goes around this thing. For guide curves, again, right click, selection manager, grab that guy, right click, selection manager, grab that guy. And as long as they intersect every profile, then we know that it's going to work out. So as we're looking at this, this thing already looks a million times better. It's nice and smooth. We don't have any sort of odd twists in it. There's one more thing that I want to add. From the guide curves, I'm going to say normal to profile for both of these. I want to make sure that they're normal to profile. This is essentially making sure that when I mirror this, I don't have a hard edge here. So back in features, I can go to my front plane, bodies to mirror, and I can knit the surfaces together. Okay, so now you see the dashed line tells me that I have tangency across that edge, so that if I turn the edge display off, I have a nice smooth entity. So even though we were working with the same essential base sketches, having it done as a surface was much easier to control. Now, of course, you can also go back and do things like on that original sketch, you could go back and simply close these off with solid edges. So delete the mirror, delete the loft, and then start manipulating these sketches so that they had solid lines closing them off. And you could follow the same process using a solid and then mirror it as well. So those are just a few different ways that we can handle doing a loft inside of SOLIDWORKS. So again, Loft is really limited by what you can do with it. What I showed you here were some basic examples. I use Loft a lot for surface patching because it handles triangular patches or patches that have degenerate points very well. So if you're into advanced surfacing, if you're doing a lot of surfacing work inside SOLIDWORKS and you run into an issue where you don't have a four-sided patch, where something like a boundary or even a filled surface would really excel, and you have a three-sided patch where two of your edges come to a point, try out the Loft. It does a great job at handling that. Really more of an advanced example, so we're not going to talk about it here. But again, explore all your possibilities. Don't be afraid to use Loft as a surface and play around with it, knit things together. You can get back to a solid pretty easily from here. And thanks for watching. I hope you enjoyed this video and would love to hear from you. Let me know your thoughts or suggestions for other videos in the comment box below. Subscribe to my YouTube channel and visit learnsolidworks.com for more SOLIDWORKS tips, tricks, and tutorials.